All right, my friends, we're going to start this thing out. We're going to start it out strong with a naive B cell. You know that that naive B cell has to go to school. Before it can go to school, it has to pick itself an antibody, a specific antibody. It does a little gene shuffling, and it gets its specific antibody. And then it embeds that antibody all over in its cell membrane. The antibody has those very specific little receptors that allow it to bind to a very specific antigen. Naive B cell passes all of its school, heads on out to the world, and patrols the body. A naive cell is going to hang out in the lymphocytes. It is a lymphocyte, so it's going to hang out in the lymph nodes. That's like the lymphocyte, like donut store where they all hang out and eat donuts and talk to each other and like see who's coming by. They kind of monitor what's going on. It's kind of awesome. And then magic happens, and my little naive B cell runs into its particular antigen. Okay? So imagine that the naive B cell, the first thing that you can imagine happening, and I'm going to try to put it over here. We'll see what happens. It binds to its antigen. Okay, done. Game over. Let's go home because it fixed everything. No, not even close. It endocytoses. It yumptializes its antigen and its antibody. So it engulfs the complex. Are you good with that? The complex is now inside the cell. Oh, you might think we're done, but we're not. It posts the antigen on, what do you think? On MHC2. Remember I said B lymphocytes were antigen presenters? It posts its antigen on an MHC2. It doesn't take its antibodies out of its cell membrane. Like, the antibodies are still there, but the act of binding with antigen initiates the whole engulfing process, and now I have a new cell. It's still naive, but now I am posting the information on an MHC2 platform. I'm actually posting that antigen. So look, I just posted the antigen on an MHC2 platform. I put two little lines there so you would know that that was MHC2, but maybe I should make a little note of that. MHC2, okay? All right, it's posted its stuff. It's still naive, you guys. It's still naive. Silly, naive little guy. Because we're not going to let it decide that it's time for all-out nuclear war. So we're going to have to somehow activate this guy. And I'm going to give you, I'm going to make my activator. I'm going to tell you who comes in and activates. It's a helper T cell. Remember I told you that there was some overlap going on here? A helper T cell that has a receptor that matches, I'm trying to make that look like it matches. Huh, what? A helper T cell that matches this antigen will come in and allow for activation. Oh, yeah, that's an arrow. And the whole point of this is that we're going to activate the cell. And I'm just going to give you a little reminder. Remember I said that T lymphocytes had to be able to bind to MHC platforms? Here's one reason why. T lymphocytes have to bind to the antigen and to the MHC molecule. So you have to be able to bind to your antigen, not bind to like every other molecule on this cell, but you also have to be able to bind to MHC. And if you can't bind to both, it's not going to work. You are not going to activate this cell if you can't bind to both. So the helper T comes in and activates this cell, and now we have a mature activated B. Activated B. And I'm not going to draw all of its jewelry because I'm going to let you remember that that is on there. But now our B is activated. Thank you, helper T. My activated B has choices. It is either, let's see, I had my helper T coming from that way. It is either going to become, I guess it doesn't matter, we've got two options. One of my active cells is called a plasma cell. And the other one is a memory cell. The memory cell goes dormant. It doesn't require all of this to get activated. The memory cell remembers, hey, this threat was real, and we had all these checks and balances, so if it comes back, I'm ready to rock. And the memory cell will transition to an activated B if it is exposed to its antigen. So you can imagine that it also has that antibody, that specific antibody in its cell membrane. The plasma cells, these guys are like crazy antibody factories. They're going to do nothing but produce, like, I'm not kidding you, like thousands and thousands of antibodies every second. They're going through so much protein synthesis to produce antibodies, and they're not producing random antibodies. They're producing these antibodies that match the specific pathogen that just entered the scene. Plasma cells are effectors. These antibodies are going to go out into the bloodstream. They're going to bind to the bad guy. They're going to signal to the other macrophages and everybody else, hey, there's something to eat here. They're going to trigger complement, which will trigger Mac attack to pop the bad guys. Like this whole thing, like suddenly we're flooded with antibodies thanks to the plasma cell. The activated B is who became that. Now, we're going to look at the cell-mediated response. We had to get the helper T cell somehow, and so don't forget about that guy because we're going to see where that guy actually came from in the humoral immune response. I mean in the cell-mediated immunity response. Dude, I'm not going to tell you what time it is.